All right, here is question number 4. Let's start with A part. We are asked to solve this particular equation, 27 to the power of 2x minus 1, multiply by 1, divide by 3 to the power of negative 3x plus 2 equal to 9 to the power of x plus 3. So I'll start reducing it from here because I know that 27 is the same thing as 3 to the power of 3. So this is 3 to the power of 3, but we already have another exponent, which is 2x minus 1, 2x minus 1. Then multiply by, I can write 1 over 3 as 3 to the negative 1. 3 to the negative 1 is the same thing as 1 over 3. But we already have another exponent of negative 3x plus 2. This is equal to 9 is the same thing as 3 squared. So we have 3 squared. But we have another power of x plus 3. Right? We are moving. So from here we can expand this. We have a 3 to the power of 3 times 2 is 6x minus 3 times 1 is 3. Then multiplied by, you see this negative 1 times this negative will give us what? Positive. So this is just 3 to the power of 3x plus 2. This is equal to 3 to the power of 2 times x is 2x plus 2 times 3 is 6. So we are going to apply one of the laws of indices here because the bases are the same and we are multiplying. Hence, we can take a base and add the exponent 6x minus 3 plus 3x plus 2. And this is equal to 3 to the power of 2x plus 6. 6 plus 3 is 9, right? So we have 3 to the power of 9x. Minus 3 plus 2 is minus 1. So minus 1. This is equal to 3 to the power of 2x plus 6. Since the bases are the same, we are going to equate the exponents, which implies 9x minus 1 is equal to 2x plus 6. Let's collect the like terms, bring this one to the left and take this one to the right. We have 9x minus 2x as 2 crosses over, 2x crosses over. This is equal to 6 as negative 1 crosses over, it becomes positive 1. This is 7x equal to 7, which means that what? X must be equal to 1 because 1 times 7 is 7. So by dividing both sides, if you like, you can divide both sides by 7. Finally, you can see that x equal to 1 because 7 cancels 7 and 7 divided by 7 is 1. So the value of x is equal to 1. Then the second question, we are asked to differentiate this function. So the B part, we are asked to differentiate 2x squared plus 5 whole to the power of 4. I'm going to show you 2 different ways to do that. But first of all, let's start with the traditional way. So if y is equal to 2x squared plus 5 whole to the power of 4, let u be equal to 2x squared plus 5 so that y becomes just u to the power of 4. Why? Because we have let the whole of this to be u, therefore y will be equal to u to the power of 4. So we are going to differentiate this and differentiate this. We differentiate u with respect to x because this is u, this is x. Using power rule, 2 will drop down to multiply 2. We have 4x. You reduce 1 here, it becomes 1. And derivative of constant is 0. Then here we are going to differentiate y with respect to u. So what do we have? We have dy over du to be equal to 4u to the power of 3 because the 4 will drop down to multiply and you have to reduce 1 from 4. So this is what we have. So applying chain rule is stated that dy over dx is nothing but dy over du multiplied by du over dx. Just observe, du will cancel du, we have dy over dx. So what is dy over du is 4u to the third power. So we have 4u to the third power multiplied by du over dx is just 4x. So we have 4x. 4 times 4 is 16, so we have 16x times u to the power of 3. But we have learned that u is equal to the whole of this, 2x squared plus 5. So this is equal to 16x multiplied by 2x squared plus 5, which is u, but u is to the third power, right? So this is dy over dx. But let me show you the shortcut. So if you have y to be equal to this and you wish to differentiate it, just take this power, drop it down. We have 4. Repeat this one, 2x squared plus 5 to the power of 4 minus 1 is 3. Then you multiply by, you differentiate what is inside. If you differentiate this one, 2 will drop down to multiply 2. You have 4. X to the power of 2 minus 1 is 1. And derivative of this one is 0. So you stop here. All you have to do is to take this 4 and multiply by 4x. This is dy over dx, remember? So therefore dy over dx is equal to 16x. 2x to the power of 2 plus 5. And this is just the solution. So now let us move on to question number 5, right?